Morning, and happy that you guys find this to be an important topic. I will introduce everyone on the panel shortly, but really we are part of the industry, so we're like you guys here, and we just want to share our thoughts and ideas. This is really meant to be a collaboration though, so please, if anybody has any input, any ideas, we're happy to take those as well. And maybe before we start, just by a show of hands, so we know who's in the room, how many of you here are wire harness manufacturers? If you can raise your hand. Okay. Of those that didn't raise their hand, like, are you representing suppliers? Are you representing OEMs? How many of you are OEMs? We got one OEM in the room. Suppliers, anybody else? Nobody wants to say. So mostly manufacturers. Really our talk today is to address the cost of what we call the broken digital thread in manufacturing operations. The impact of the digital thread being digital to analog in our industry, and how do we, as industry partners, really address it. So I'll start with describing what happens pretty much every day for the manufacturers. You get an RFQ package, you start reviewing the drawings, and then this is when the fun starts. There's a whole bunch of assumptions. There are missing connector specs, incomplete bills of materials, all kinds of different documents like workmanship specs, no proper tolerances on the drawings. Maybe there's no wires defined, right? They're as required. Sometimes they don't even define the wire type. And what are you supposed to do? You need to quote it, and you need to quote it quickly. So the job is quoted. A week later, your salesperson comes and says, "Hey, Joe, great news, we got the order." And this is when the fun really starts, right? You move it to the production floor, and then your production team says, "What are we doing here? The terminals aren't defined. We're missing parts. I don't know what is the right spec to work to. The back shell does not fit the connector. What do we do?" So the technician stops the product on the floor, goes to the manufacturing engineer. Manufacturing engineer says, "Oh, Jose, you were right. This is missing all this information. Let me go back to the customer and ask them to provide more details onto the drawing." The OEM, that engineer, is already working on a different product, and he's not available to answer, and you need to chase him down or chase the person that's been assigned, and that the process starts again. I want to know that the scenario that I described, by a show of hands, can you raise your hand if this is familiar to you? All right. Almost everyone in the room, right? And I'm sure those that didn't raise their hand probably would agree. This is not a quality failure. It's not a failure of you as the manufacturer. It's a data failure, and it's really a failure of our industry to educate our customers. And this is really what we're gathered here today to talk about. So I will start with the panel. And as I said, we've got a group of really accomplished and passionate industry experts. I'll start here with James Green. James, maybe you want to introduce yourself.
Sure, I'll do a quick intro. Hello, everybody. My name is James Green. I work for MBDA UK from England. So over here, especially to show you this time. I'm representing OEM in our panel, and I spend a lot of time working where design intent meets manufacturing reality. So this topic is very real to me. So I'm pleased to be here.
Hello, everyone. My name is George Jacob. I work for Neutron Systems in Walton, Virginia. We are a company in wire and cable harness contract manufacturing. I've been in business for 40 years.
Good morning, everyone. My name is Manas. I lead the supplier industrialization at Lucid Motors, responsible for everything with products.
So we are all part of a broader WEMA committee called the IAT. It's the Innovation Committee, subcommittee under WEMA, as well as about 6 or 7 other peer members. And this is certainly one of the main topics that we are trying to help the industry solve. So I'm going to talk a little bit about the context of the digital thread or the digital twin, which exists everywhere in the industry, and how it is broken specifically in the wire harness domain. So it really starts with the OEMs, right? Our end customers, they design and they design typically in digital systems, in CAD and ECAD systems. So they're very much understanding and committed to the design, digital design process. They cannot really do it any other way, especially in complex systems. But there are 2 gaps. First gap is those OEM design engineers have never built a wire harness. They don't know what is required to build a wire harness. They don't know what they need to specify and whether it's producible or not. And they don't have a good software tool that helps them understand those design requirements as they are designing. They next, regardless of the fidelity, the accuracy, or the validity of the design, they take their digital design, they print to PDF, and they send it to you guys, the manufacturers. Okay, 90% of the data transfer in our domain is in PDF. Very few OEMs give their customers proper digital based data. And even if they do, most of you probably can't read it. So it's actually when they send these files, you probably go, hey, can I just have a PDF drawing because I can't read what you sent. So you as a manufacturer, you receive these PDF drawings, and that's when you have to start reconstructing what is really there and what's not there. It moves to quoting, BOM completeness. So the completeness, having everything defined, is the #1 bottleneck that we usually see in quoting. And you start making assumptions. Okay, did they really mean this, or did they really mean that? Or maybe you don't even know they missed things in the BOM because you're just quoting quickly. And then, as I said, you get the order and it moves to your production planning. They start building the work instructions according to whatever was in the drawing. Nothing was captured. That moves to the shop floor and your operators are interacting with the product the first time. That's when many of the errors are found. Over 50% of the errors are found in production. After you've bought all of the materials, and you scheduled your production floor to build this product, because most likely the customer is pushing you for quick delivery. You then have to go and figure out, are my test programs correct? Did I buy the right mating connectors? Because maybe the connector is being changed. And so, we go back to this single broken handoff, starting with the OEM, starting with the design, cascading throughout the production floor. And this is the context of our conversation today. So this isn't anecdotal, it's an industry-wide problem. We conducted last year an industry survey asking them about people like you. Maybe some of you have answered these surveys, asking you what are the top problems that you're facing and what would you like to solve. 90% of you confirmed that you receive the requirements from your customers in PDFs. Over 80% confirm that you encounter design problems, and often they're in the production phase. Over 50% of you have said that you rely on tribal knowledge of key people. A few people know what to do with these drawings. A few people know how to understand the end customer requirements, how to identify what's missing and what they intend. And over 50% have asked for design validation to happen before the drawings get to them. Does that resonate for everyone? Yeah, I got a lot of nods here. So let's talk about the root cause and really, where does it break? So again, I'm going to ask the question I did before, but I'll ask again. How many of you have had a job arrive on the floor that didn't match what was quoted? Can you raise your hand if you've heard of a job making it to your floor that didn't match whatever you quoted? Around half of you raised their hand.
I don't know. I mean, it reached a floor with what the customer wanted to be on your floor, but it doesn't work.
Thank you. Yes.
Well, what happens is you've got heat shrink called out, you have something gets bent somewhere, but the job got to the floor, and this one got to the floor.
Yeah, absolutely. It's a better restatement. The job made it to the floor like it was quoted, but it's not what the OEM wants you to produce. It cannot be produced the way it was quoted. And now you've got to change it. Maybe you need to reprice it. You need to get the OEM to confirm that you're okay to change. Maybe they don't even allow you to change the price. They say, hey, the other guy, your competitor, built it to this drawing, so something is wrong with you, right? Yeah. So we'll move this to our panel, and I'll ask George or Monesh, or both of you, walk us through what happens when a design package arrives incomplete. Where does it hit you in quoting, planning, or the shop floor?
Obviously, it's going to take us first of the quoting stage. Like, there's a lot of time that we have to spend understanding of what the requirements are, and typically RFQs are sent by the purchasing department. So we have to go back to the purchasing department. They have to go back to the engineering department. I can give you an example. I recently received a quote package that had 20 drawings, and 14 of them had the mill W16878/4, and the rest of it had /6. Obviously, there is a significant cost difference between the 4 and the 6. And then I decided to ask them, and they said, sorry, it's a mistake, we need 4. So imagine how much of time that we are spending trying to quote for what the customer requires. And imagine if I didn't ask the question, I may order the /6 wire, which would come up expensive, and maybe I won't make the job because my price is higher than my competitor. So, we experience this on a constant basis every time we get a quote package.
I'll add some color to that a little bit, right? So in addition to leading supply chain activities that use it, I'm also an investor in a small harness manufacturing. Right? So we get packages, what George mentioned as well, right? Very recent example, 19 harnesses that came quote, not a single harness could be quoted. There's a lot of waste that's created, right? And ultimately it gets baked into the product itself. Right? So that's the problem we're trying to solve.
And again, just to add to that, well, imagine we took some sessions, ordered, and then we get an order, and it doesn't work. And there's a production floor. We realize that what we quoted cannot be built because we took a shortcut in the quoting process, trying to say, okay, when we quoted, we just used the back shell that they asked for, the connector, only in the production stage after purchasing, made the purchases of all components that we realized, oh no, this won't fit. So, enormous amount of our time and cost in these instances.
James, from the OEM side, typically, when does your team find out there was a problem with the design data that you sent? Is it days later, weeks later, or months later?
So I'll be honest with you, it's usually a lot later than I'm comfortable with. It's usually at first we'll find issues. And I've learned the hard way. I've learned the shop floor is a very expensive place. I will design a review. The problem probably grows in my industry, high reliability and safety. If we don't catch these data errors during build, then they'll leak into service, which is an even bigger risk for our pieces. Processor problems, this is we really have to start thinking about how we catch those errors. And that's what we're trying to do here. We're trying to look at how we can close that feedback loop between design and manufacturing, and how we can capture these data errors digitally before they become physical.
Bonesh, is in your opinion, is the root cause a technology problem, an education problem, or a culture problem?
I think it's a mix of all three. Like primarily, it's an education problem. Right? What happens is whenever engineers are releasing plans, right, there are certain there's a checklist of items, right, that they should be verifying before a drawing gets released, and 99% of the times that doesn't happen. And I think the biggest challenge is the education portion of it.
Absolutely. So what bad data actually costs? This is my quote here. We didn't find design problems until we started manufacturing. So I spent over 30 years as a manufacturer prior to my current engagement. And we were building wire harnesses for top high rel domains in aerospace and space. And over 50% of the time, we didn't find the problems until we started manufacturing. And this has a cascade effect. Nobody budgets for it. Nobody budgets for the impact of the design review happening on the floor and then having to spend the resources to figure out what is really meant. Of course, when we communicate to our customer that there's a problem, we've got to do it really carefully. We got to look smart and not dumb. We've got to do our research, spend a lot of time. Meanwhile, everything is stopped on the production floor. Our production team was scheduled to build this job. they're not building. And then we find out that we've got to buy a new part and it's got a 12-week lead time, right? And we got to, figure out how do we tell the customer that not only you're not going to get the product in time, it's going to be 12 weeks late. And oh, by the way, we're scrapping a whole bunch of parts and it's going to cost you, an extra $10,000. This is not a fun conversation that anyone wants to have. They see it as you passing on the cost to them, but you're not passing all of the cost. There's a huge impact to your plant. And so in this poll that we did, the industry poll, 83% of the respondents confirmed that they encounter design errors that affect production. A third say that it happens in more than half of the jobs that they process. I certainly saw the same in my production floor. And as we said, the cost isn't in the quotes. The cost is at every stage that follows afterwards, and it is a compounding effect. And so this is truly an operational integrity problem. It's a financial problem, and it's a problem that the industry needs to address and tackle, because we all know the OEMs are pushing for cost reductions and improved performance of their suppliers. But this is not an area that they are taking responsibility for. Most of them are not. I know we've got one OEM here in the room, maybe a few, and I think everybody that's listening to this talk is certainly aware that it's important. So we want to move to what is good? What would be the ideal scenario? And I call it a perfect Tuesday. So as we said, in today's environment, the PDF arrives, you manually reconstruct the BOM, you call the OEM about missing parts or missing requirements, you wait days for a response, you spend as much as 20 to 40 hours of engineering before your sourcing team actually can get going. The quote goes out, it could be 2 to 3 weeks later. And by the time this all happens, the customer says, I couldn't wait. I went to the supplier that built it before. Really, our vision is the OEM finishes the design, they hit send, properly structured data arrives to the manufacturer, the bill of material is already validated, any missing components are instantly flagged, parts are cross-referenced to the supply chain, as George said. If it's a /6, maybe we say, hey, it should be a /4, and it happens automatically. The quote is generated in minutes. The same data flows to your cut and strip machines, to the Comexes. No manual entry, no phone tag, no re-engineering on the floor. We're not fighting fires. We're focused directly on creating production and technical value through the supply chain. Wouldn't that be a dream come true? We're all working on this, and certainly there's a lot of work for that to happen. But I think there's huge commitment from WAMA, from the WAMA leadership, and we have in the back here Dave Bergman, the executive director of WAMA. So as you can see, it's a very important initiative for the organization. So knowing this vision, I want to take us back to, when the data is right, what changes? George, when you've received a complete structured data package, what changed beyond the quote? Did it change how you plan production, how you wrote work instructions, how you deliver the product?
I would say that is a perfect Tuesday for golf, because everything goes smoothly so that I can go out and play golf. But it never happens. But What I'm saying is obviously, everything will happen in a breeze. The quoting process, right at the quoting process, we know that this is a product that we are going to build correctly and very less room for error. So obviously that's it success if we can get everything to be lined up.
Monesh, assembly work instructions and production documentation were rated as one of the top innovation priorities. What does the industry lose today by building from the incomplete data?
We touched on this earlier as well, right? I think any incomplete data has multiple downstream effects, right? That includes maybe working instructions, discussion instructions, all of documentation. They don't just going back to the waste that's being created, right? And all of us has financial impact, right? And there's a dollar amount that needs to be associated to waste. And yeah, that's what I would believe is the cause of incomplete information, or the effect of an incomplete information.
And again, just to add on to what I said, at most contract manufacturers, they really do not have an exact cost implication of this, like your the downtime or the time that you spend sending emails to engineers. Like the repeatability of this whole process. Because if the drawing is not enough, the data that you got is not enough. So 3 months later, if you were to build the same product again, what is the guarantee that these questions won't arise? So typically what we do is we have a folder, so we have a drawing, and then we have also the emails that went back and forth. So should this come back 3 months later, then you know what it's tremendous amount of time that we've spent on trying to do all this stuff.
And James, as the panelist representing OEMs, you mentioned the impact of sort of the design review and the production floor and even potential quality issue. But can you dig deeper into the downstream cost when your supplier doesn't execute accurately? Where does that show up for you, and what's the impact?
Okay, so of course it is financially the bottom line when we have to pay the scrap, pay for rework. I'm more worried about the hidden costs, the ones that aren't tracked in the spreadsheet on the Power BI dashboard. And George, of these really starters, questions and emails, this leads to delays. Then we're having to be reactive, and we're looking at redesign, we're looking at repaying, we're looking at expediting material to meet the schedule map, change our plans for that schedule. And this all has an impact on critical milestones. These are the costs that aren't tracked. And if we can't measure it, we can't manage it. So this is the real issue, not the bottom line. The costs that are hidden in weeds really need to be brought out and understood so we can really understand that cost. So yes, we see the cost financially sometimes. Often we see it operationally. We always see momentum. So it's a big issue.
I'll share a little story from my former life as a manufacturer at Alcom Systems. We worked with a very, very large company, a prominent company that was doing some amazing work, and we were doing a lot of their NPI builds. And our first quarterly business review with this company, a whole team came to our plant. We prepared for days for this QBR with our slides and our matrix of what we've accomplished. And then they said, we want to start the meeting. And they pull up a slide. And of course, what is this, a QBR, a OEM to supplier QBR always start with? On-time delivery. So they show a graph of our on-time delivery to them. And I can tell you, I can still feel it in my bones. It was 0% OTD. And I was shocked, right? Because that's not what I was measuring. I was measuring something completely different. And so, I'm getting ready for the hammer to fall, right? Like, you're a 0% on-time delivery supplier. That's not a supplier that you typically do business with, right? Well, guess what? What was the next slide? How much more business can you handle for us? And you're thinking to yourself, wait a minute, something is wrong. Like, we perform so poorly, but yet you want to double the business. And I'm talking about a lot of critical work. And so they said, we know that we are the problem of your 0% on-time delivery. It's not your fault, it's us. That's an amazing position, because usually you get skewered when top management sees that kind of performance of a supplier. They don't work intimately with the suppliers. It's done by a commodity team. But yet the commodity team stood up and said, we take responsibility. We know our designs are bad, and we know that you know how to fix our designs and execute better than everybody else. So, we'll work on getting better, delivery and forecast, but we want you to give us more capacity. We want to really, build together. So this is something that's really prevalent and really important, I think, and I'm sure many of you feel this with your relationships. So, I want to this isn't about just sharing the problems. We actually are spending real time and some resources, but our personal time, we've got a committee, as I said, of about 10 people. This is the Innovation Advisory Committee that is working under WEMA. And we have a few main initiatives. First is, we call it the data exchange standard. We're trying to define what is the right fidelity, the requirements of the data exchange, and the manner of data that it should be exchanged in the industry. So it's really two things. What is the minimum, what do we call it? Minimum design requirements that we expect the OEM to deliver to the manufacturers. Is the BOM properly defined? Are the workmanships properly defined? They give us internal part numbers. Did they give us an AVL? Right? Is there a wire list or from-to list in the drawing? Ideally, they tell us what the wire lengths are on the drawing. That would be nice, right? So we're building a checklist. And the goal of this checklist is to begin educating the OEM designers under WEMA with IPC support, and have some sort of a methodology where we transfer this know-how, because I really think the designers don't know the impact and they don't really know what they need to do. We need to train this, and there's going to be a huge effort, hopefully, that we can undertake to get this done. The second part is, once they're educated and they know what they need to do, is how they deliver it to the manufacturers. Do you still want PDFs, or would it be nice to get digital data that you can read, right? And you can move it into your downstream process, whether it's your quoting system, your ERP systems, your planning systems, or actually to reuse this to move it to your test equipment or production equipment. So this is also a very active initiative that is happening at WEMA, and that we are spending our personal time. We don't get paid for this work, Okay, we are volunteering because we really care about the industry and we want it to be successful. The next main initiative is quoting automation. This is one that's near and dear to my heart with the work that I do at Cable Tech. But there are other solutions, and we're happy that people are paying attention. We want faster turnaround times. We want to do it with more accuracy and with less manual effort. It shouldn't take 3 weeks to turn around a quote. It shouldn't take 10 hours of engineering and purchasing time to figure out, what the right price should be. This can be done a lot more efficiently. And, we're working with many manufacturers to benchmark the before and after. We've seen a lot of great success, and we think that there's a lot of opportunity for improvement. And then, as I mentioned, our long-term goal is to create an IPC 620 equivalent for wire harness design, right? We know that IPC 620 is the standard for building the wires. We know that, what a good crimp and should look like under IPC 620. Why not help to define what a good drawing looks like under IPC 620? Again, Dave from WAMA is here, and this is certainly something that he agrees with, and we're looking at as a board to see how we can make a difference. So nearing to the end of this panel, I'll end with what does the industry do next? George, I think you said this. A 3,000-mile journey starts with a single step. And we took the first one. What does step 2 look like, and who has to take it?
Yeah, so any difficult thing, the first step is the line. This is the most difficult step to take, and you've already taken that. Thanks to one, thanks to we recognizing the need to have an innovation advisory committee to for the wire harness industry, because we are traditionally not known to be innovative in the way that we do. And I'm guilty of that as well. My company has been in business for 4 years, of which, and what I'm requesting you as contract manufacturers, all the industry, is to take the next step. I had found excuses not to thinking that, okay, for example, the coding process, the automation is not ready enough. But if it is 70% ready, then maybe we should jump into it. And because there's no perfect solution. And a lot of the second steps or the forward journey will come from people in the room, people like you in the contract manufacturing and OEMs and stuff like that. Whether you take the steps and wondering, are we perfect? No. Are these 70%, 80% there? Yes. And maybe it's a good idea collectively to go on and move it.
James, related to the data standard, we talked about the minimum data exchange standard. And what would it take for your organization, for MBDA, to adopt this type of standard? And critically, is there something that the standard should not include?
So, 3 things I'd say. It's got to be useful. It's got to be usable, and it's definitely got to be trusted. So useful, it's got to be solving practical problems. So some of the issues were mentioned: faster quotation, fewer errors, a smoother release to build. Definitely got to capture those points, and that will make it attractive to businesses, make people want to have the standard. It's got to be usable by all, so it's got to be open source. Can't have any high license costs associated, no complex infrastructure. For me, ideally, it'll be fitting with our existing tool chains and workflows, and find out trusted. Key for me here. In my world of highly regulated systems, we need to have a standard that we can manage traceability, we can manage revision control, and opposites be security. What was the what should it not cover? So when I think of a good standard, I think it's the foundation that builds trust as a good standard. But what we don't want to see is a ceiling. So it shouldn't there progress or innovation. I think that's key for us as a business. It shouldn't try and do everything on Rev 1. It shouldn't try and solve every niche use case as a starting point, or just risk task paralysis if we try and do that. I think the dream for me has IPC 620 sort of the gold standard, the Bible for physical workmanship, to have a strong foundation for digital workmanship, be that through our standard, be that through education. I think that's a great read for my company, hopefully the right industry as well.
Thank you. And Monesh, if the industry solves the broken digital thread in 2 years, and in my opinion, we can't wait 2 years, we got to do it now, right? But we solve it not just for quoting, but for the entire design to production handoff. What becomes possible that isn't possible today?
The first thing that will become possible is you'll be able to turn around quotes a lot faster. Like we'll be able to build a better quality product at the first go, right? And believe them, George touched on it, right? It doesn't have to be 100% good, right? I mean, we have taken the initial steps, right? Now, as an industry, we come together, right, and take the next steps in getting this data integrity and minimum design requirements for the engineers out there.
Okay, so I've got a few plugs here before we open it up to questions and feedback. First of all, if this resonates for any of you and you would like to participate in our innovation advisory team, please feel free to come to me. George Jacob is co-chair, or Dave Bergman, and we would love to have a conversation with you. If you want to join our quoting benchmark, because this is something else that we're doing, is figuring out how long it takes, how much resources, what is the turnaround, can we make it better? If you want to join that as well, come see me. I've got a few more plugs. We're here in the WAMA conference. It's EWPTE, but it's organized by WAMA, the Wire Harness Manufacturing Association. Not everybody in this room may be a member, so we just wanted to say we'd love for you all to join WAMA as members. And for us here, what has WAMA done for us? We're learning from each other's experiences. As you can see, we met in WAMA. We didn't know each other before. We're learning best practices. We've created a great network together and even friendships. We can call each other for help when we need to. We get a lot of great educational materials and insights. We connect within the ecosystem. We connect with suppliers, and we even meet new customers in our annual WAMA conference. We meet OEMs as well. And really, we're developing the tools for our future together. So if you want to join, if you're not a member, there's a great offer, 25% off. Visit the WAMA booth 829. Yeah, visit the WAMA booth 829. They'll be happy to sign you up there and highly recommended, and we need to grow the industry together. And one more resource from the folks at Cable Tech. On your tables, you have a card. It is a wire harness tooling search tool. So we know that many people struggle with finding the right tool, and you spend a lot of time and engineering resources. We've opened up a free tool for the industry. You don't need to be a Cable Tech customer. You don't need to go into our application. It's a web domain. Anybody can get access to it. It's not gated. Other than, of course, we need to sign up with your name and email address. And we spent a lot of time building a tooling library. And so we wanted to give this back to the industry, put in the contact, put in the connector. It's not perfect, as George said. Maybe it's 70% complete, but it gets better and better as we see the data that the industry needs. And, we'd love to get feedback on that as well if you think something is missing or incorrect. So with that, I want to open it up to the folks here. Any comments or feedback would be really appreciated.
Can you describe again a bit about the origin of
Yeah.
the manufacturer, what that media would look like? You want to restoring that physical thread. Is your kind of vision that the PDFs, it's all some sort of you can file or data? It's no, we're supposed to do PDFs, but you have some more universal tool language like Excel spreadsheet that how do you fucking like? Yes, I was just curious what are your early visions of what that would look like?
Anybody want to take that in the panel? Okay, so the question for the room is, what is the vision for that digital thread for the industry? Is it a CAD format, or is it still a PDF with some supporting Excel type data? We believe it should be in a more native digital format, like an XML type data format that is supported by all the CAD companies. You mentioned Zuken or Cadonix or Rapid Harness or Capital. We've talked to other verticals, like the automotive verticals, with their standard, the KBL, and they've got KBL and VEC, which Dave is working on with counterparts from those committees. But we want a standard that's, somebody here on the panel said, is available to everyone. It's not dominated by one CAD company, that you don't have to pay for a license, right? Or maybe minimal cost for a license to read it. That is not too complex, because some of those standards can get highly complex, and that brings in the needed information, the minimum requirements through that data. So in this world, the PDF is not needed, because we know the topology, we know the geometry, we know how things connect to one another, how they're intended to connect, and we can read that and convert it into any other medium that we need. And frankly, I think that this is certainly possible, but requires a lot of collaboration and coordination from different industry players.
So I'm a harness designer, so one of the tables, the trucks run all the time. But it sounds like we're pushing for it just here, gone, the front, and more education. I mean, I can see how that would work, but I guess unless these tools are controlling a type of issue, like the shrink tube internet and the back shell, we'll see how those controls and that software, we're really not adding as much. You know what I mean? We're still going to get those drawings. So I guess my question would be, like, are we sure that these tools would actually solve the problem? No matter what, as an engineer, you're still gonna have like
Yeah. So again, the moving the data digitally is only one of the problem. Knowing, I mean, what's your name? Daniel, do you mind saying which company you're with? BAE? Yeah, BAE Space. And obviously you care about this issue. That's why you're here. So thank you for joining us. And Daniel said, okay, you give me a standard that I can output to, you give me education that I know I need to give you an AVL and a bill of material and wire lengths. I still can make mistakes with bad parts or calling out the wrong back shell to the connector. So certainly there should be part of this are design validation, design rule checks that you run that are not dependent on how you set up your own library, because that's part of where the mistakes are is, the library may be incorrect or you never had time to build that library for the parts that you're working with on this program. It's not like you have months of advance notice when you have to start designing wire harnesses, right? And I think that has to be a part of the overall solution, are the validation checks and validation tools. Those exist in other CAD domains. They certainly exist when you design a mechanical system. And I don't want to say there's no reason why they don't exist in the wire harness domain. It's really complex and there's lots of data and no standards to specs and component specifications, but we are working on that. And I can tell you that from my company's standpoint, Cable Tech, we have spent 3 years building part libraries for this exact reason. So, because that's where it starts, is getting a lot of data on components. So it is something that will be solved and should be worked in line with this overall solution. And I don't think we're 2 years away. I think we're going to make that happen sooner.
Just to add a couple more together, very pertinent points. When we moved from wood grains to color gray, we are getting the same errors in a color process that we put in before. So transferring to XML without adequate checks or validation for the design is not going to make the process better. But there's better transferability if everything is aligned with the history of transfer process.
Yep, in the back. Yes.
So, I know you guys been working with Prabhapa. Yes. Talk a lot of it back in Vegas and February. So, is it gonna work for the different industry? Aerospace, automotive, medical. It's gonna be. Is it gonna be some minimal requirements that they're gonna say no? It's just too basic. But it will work for everybody. Have you guys thought about how you actually make it work for all of the design in different industries?
Yeah, obviously the more industries we cover, the sort of the complexities, we have to address those complexities. Frankly, the automotive industry has many of those standards or doesn't, and they just accept that that's the way to work. And there's a few really large companies that work with the tier one automotive. We're not trying to solve their problems. We're trying to solve your problems and the things that you're dealing with. And that does cover aerospace, and that does cover medical, and that does cover off-highway and white goods. And so really, I think this is sort of driving how we define it. And it might be that it has to be different requirements for each vertical, and we certainly have in our team people that are very familiar with those verticals, the different verticals. So it's not meant to be representing only aerospace per se.
Or maybe in one standard and they have like some chapters of each. So we are
Class 1, Class 2.
Just like IPC. IPC Class 1, IPC Class 2, and IPC Class 3, absolutely.
It's just like the history of all planning. I mean, we all started out working from like Martin Marietta, workmanship, instruction. I mean, I think all of us had some large OEM that did indeed end up a workmanship standard that we all then worked from, and then we all evolved. You see people that have their own workmanship standards very good.
Yeah.
And just hey, there's some basic things that these you can't do. We're the ones that see it, the errors, so we should be ones helping the scientists. Hey, this is the company wanting. This is the class 3 way to make it wrong.
Agree, 1000%. Yeah, and I think it needs to come from us as manufacturers because we are feeling the pain. We're feeling the commercial pain. We're feeling the execution pain, and we want to do better. We want to, be effective and efficient, and we've got to help drive this to our customers, to the OEMs. And so, if WEMA invests in defining and delivering the tools, we will certainly ask our members to help introduce us to your customers so that we can have the ear to educate and have those conversations and bring them into this discussion. They're not all aware of this issue and what is the impact. Anybody else?
Some of it you're never going to be able to just happens. I mean, no matter how much planning you've done, you get tips, and you're just going to.
Yeah, exactly. That's why we're trying to find that starting place. Like we said, this has been done in the automotive world. Now we're trying, and you'll see it. You see it there. You see it with Phenonics and Comax. These pockets of additional thread go between design and manufacturing. Now the job of our team and our industry is to make something usable for everyone, not just the small ones.
Well, I think we are at time, so I really, from all of us, we appreciate all of you being here, being engaged. If you're interested to help us in the innovation advisory team, please come and see us. If you're interested in joining as WAMA members, as I said, there's a good opportunity, and feel free to use the free tool search and let us know how that's working for you. Thank you.